So students, our next topic is optical property. So what is optical property basically? Optical property is how food material respond to absorption of electromagnetic radiation in range of optical wavelength and frequency. Okay, this includes visible light, color, but also includes transmission, reflection of the light. Okay, so this is useful for sorting, grading, maturity, surface color for the determination in food products. Okay, and the technology used means how we can check these properties with the help of hyperspectra, multispectra, infrared imaging, and computer vision system. These are some technology through which we can find out the optical properties of food. For example, if we want to sort out this lemon, okay, then these optical properties, they will check how much part is more green, lesser green, and yellowish part. Okay, then it make conclusion कि okay, whether 50% of part 50% जो हमारा part है वो yellowish है, 10% part is greenish, and 40% is between them. So we can make the conclusion that product is not good for the use. It don't attain its sourness, TSS, and all other characteristics. So we use this optical property for sorting, grading, and determining the other quality of the product. Okay, so what is 2 means when this is food material. Okay, we can assume this one is our food material. So when light incident on our food, light incidence on food, then some part reflects, some get refracted, transmitted, refracted, and some get absorbed here. So now these all scattering, absorption, refraction, reflection depends upon the food composition. Food compositions means how much it contain carbs, vitamins, protein, all that, water. Okay, we can also use this property for finding out the turbidity, that is quality of our juice and alcoholic and non-alcoholic beverages. Okay, we can see that there is some turbidity, means there is some cloudiness, haziness in our juice, where this water is don't have any turbidity in the nature. Okay, so once we determine the turbidity of the juice, then we can use further treatment. We can pass out for filtration so that the suspended particles of this juice get separated out and we make it a clear juice. Okay, so why turbidity occur? Turbidity, as we know, that when we make some juice, extract juice, then it also has some solid particles. So when these solid particles are suspended and light incident on this, then our light get scattered out. So our juice get appear in cloudiness, haziness. For equipment like turbidity meter and all based on these properties. So now our next property is dielectric property. As its name suggests, dielectric. We know di means हो गया हमारा 2. So dielectric means two electrical charge. Basically, dielectric means insulating material or poor conductor of electricity current. Means when we placed dielectric material in an electric field, no current flow but polarization occur. What does it means? Means, for example, if we are taking example of water, H2O. Okay, means it can have H plus and OH minus. So now this is क्या? Bad conductor. Means if we placed this in capacitor क्या है? An example of dielectric material. So instead of flowing ever current, it don't move from one place to another, means current is not passing. So when we apply a electric field in capacitor, then our H plus and OH minus get displaced and they get polarized. H plus, OH minus, and now this is OH minus, H plus, like that. We are making the polarization. So dielectric properties are basically used in microwaves. How microwaves? We have H plus and OH minus. So means food contains large number of molecules of water. So when electromagnetic wave get penetrated into the food, then these H plus OH minus get oxalated from their position. So, and the oxidation is we can say oxidation or polarization process is 1/10, means 1/10 of second, means very few seconds it take place. So due to this polarization, friction occurs, and this friction causes heat generation. So heat is generated within the food material, means we don't require to provide or supply heat externally, just like we supply a heat to our gas burners. So where we can use these properties? Dielectric properties can be used for drying, sterilization, pasteurization, and thermal processing. How? Means when food can generate heat internally, then for drying, sterilization, pasteurization, we need heat. So if we generated the heat internally and there is no need to apply heat externally, so means there is less energy loss, means conduction, convection, and other losses which occur in traditional heating. So this is advanced heating technology we adopt in our food industry. So we are reading this property for utilizing this application for making microwaves or checking its quality, how basically food behave when when we put it in microwaves, like that. Okay, so now our next property is acoustic properties. Now, as we all know, acoustic means something related to sound. Okay, means type of energy propagation through medium by means of adiabatic compression and decompression. Just like when we speak, sound is produced, like in any musical instrument like guitar, tabla. So these are some example of acoustic properties. So now how we can use this acoustic properties in our food industry? Okay, we know if we make a curve between time, this is amplitude, then we get sinusoidal curve nature, means this one is compression and this one is decompression. This line shows normal air pressure and this below line shows pressure decreasing and this shows pressure increasing. So our sound wave moves like that, and due to compression reciprocation we can hear the sound. Like vibration can produce by our vocal cord, so we human produce the vibration like musical instrument, women beat, this type of sound is produced. So longitudinal waves are basically responsible for the sound production. Okay, and this sound can be we feel in solid, liquid or gas. So we know that solid basically have a strong compaction, like that liquid are at little bit more distance and gas have more distance as compared to both. So the speed of traveling sound is more in solid than in liquid and then in gas. This is just similar to our conduction. How? Means when solid particle we get it into heat, then one particle gives its energy to another, then another, and like that this whole metallic part get heated. Like that sound waves also hit one particle to another and we hear the sound. Okay. So where we can use this acoustic property, we can use this for determining the quality of attributes such as crunchiness, crispiness, water activity and firmness of the food material. For example, if we are breaking this bigger, then some sound is appear. So when we are finding that it gives some sound, we assume that no, this biscuit is good in quality. But if it gets some moist, then the sound get decreased. So we can assume, or we can make a conclusion that our biscuit or any product get degraded for quality and consumer will not accept this product. So for quality determination we can use these acoustic properties. Similarly, Lay's chips, we can find any property from this acoustic property. And now next is our ultrasound. So first we study sound and now we study ultra. So ultra means extremely, and sound we already know that vibration that progress through medium by means of compression and decompression. So ultrasound is sound wave with frequency higher than upper audible limit of human hearing. Means its sound is basically greater than 20 kilohertz to many gigahertz. Normally, what frequency of sound we can hear is from 20 kilohertz to 20 kilohertz 20 hertz to 20 kilohertz normally. Okay, so like that. Up now, our next question is how we can use this ultrasound. So ultrasound is basically, ultrasound can be categorized into two forms: low frequency, another one is high frequency. Okay, so this low frequency can be used for non-destructive analytical analysis of food. Okay, and this high frequency for physical disruption. Okay, means for finding the quality, like for, if we take the example of titration, we all know about the titration. So if we want to, for example, if we want to find out the titration value of this orange juice, then we have to first peel out, then extract the juice, means we have disrupted the orange. Okay, so but now this is a new technology through which, without destructing, without peeling the orange, we can find out the titration value of food. Like that, high frequency, we make physical disruption, means some poration, and we change the structure of that food, and through which we can increase the drying rate. We can also kill the microorganism, as we know that, means microorganism structure is very small, means we cannot see. So by applying this ultrasound, microwave can easily be disturbed, their DNA, RNA can be changed.